Hello everyone. Today we will be discussing read after write consistency. You might have heard a lot about eventual consistency and strong consistency. So what is this read after write consistency? Let's understand that in this video. Let's get started. Many systems, especially social media platforms, are eventual consistency systems. This we already know from CAP theorem that since we are prioritizing partition tolerance in a distributed system, we can only have either consistency or availability. In general, for social media platforms like Instagram and LinkedIn, we prioritize availability and thus we sacrifice consistency. So these systems are not strongly consistent. That means, let's say you put a post on LinkedIn or on Instagram, it might not be that immediately your post be visible to all the followers. It will eventually be visible to other followers, but not immediately. So it is not strongly consistent, rather it is eventually consistent. But for a writer, they should be strongly consistent. If we change our bio on the profile, we should be able to see the updated bio even if we refresh the page immediately after updating. What does this mean? We just discussed that social media platforms are eventually consistent. But if you post something on Instagram or LinkedIn and then you refresh your page, should that post be eventually consistent for you or it should be strongly consistent? The answer is it should be strongly consistent. Because if you have put a post on Instagram or LinkedIn and you refresh the page and you don't find the post, to you it will look like the rights are lost. And then you will retry it. So eventually you will have multiple posts, right? So for a writer, for their own post, we should have strong consistency. And this is the concept of read after write. You are reading after you have written. So your own writes should be strongly consistent when you are doing a read, right? Let's take an example. This is the YouTube channel on which you are watching the video. Let's say I go to the description and then I put a 3 dots at the very last of the description. I click on save. It is saved. Let's say I refresh the page and again go to the description. Do you see these 3 dots? They are immediately visible to me. It might be that to you, if you refresh it, it might be just 1 dot. Because for you, the system is eventually consistent. But as a writer, I should be able to view the latest update to my own changes. And that's the concept of read after write consistency. So you got the concept that if I am reading my own writes, then those writes, the latest state should be visible to me. For other users, my followers, or for public post, they might be eventually consistent. That is fine. So this concept we already discussed. I have put a post, I refresh, and if I do not find this update, to me it will be a perception that my rights are lost. And this can lead to some confusion to the writer, that what happened to my post, why it is not visible to me. Was it lost, or there is some issue with Instagram or LinkedIn? Anything is down from their side? So that's the issue. So what is the root cause of this? The root cause of this inconsistency is writing and reading from another. See, the concept is very simple. If you have a single database instance, then you are writing to it and then you are reading from it. So the writes are going to the same database and reads are also done from the same database. So there is no inconsistency. Whatever you write, you will be able to read. Not only you, anyone will be able to immediately see the changes. So this will be a strongly consistent. system, right? But let's say we consider another system, which is write is going to one database. Let's say it is the main database, and this is the replica. But the replication which is happening is synchronous in nature. So immediately when you write, those changes are replicated to second database as well in a synchronous way. So that means immediately you get a success only when the writes are written to both the databases, first to this, then to replica. So it does not matter if you read from the main database or the replica database. Your writes are persistent immediately in both the databases, so there is no inconsistency. But consider this, a third system which is the most popular case, where you are writing to one database which is the main database, and you are reading from the replica database. So write is going to one database, reading is being done from another database, and these writes are being replicated to replica database asynchronously. So there is a replication lag. There will be some time for the writes to propagate from main database to replica database. So this replica might be on older timestamp, and the main database is always on the latest timestamp with the latest changes. Thus, since writes are going to one database, read is being done from another database, and there is a replication lag. That's why this inconsistency happens. So the root cause of this inconsistency is writing in one database instance and reading from another database. So you got the point, the root cause of this inconsistency. So how do we cope with this situation? How do we remediate this inconsistency? This suggests that writer must use the same database to read to which write happened, at least till replication happens to each instance. What does this statement mean? So this root cause suggests that whoever is the writer, their read request should go to the same database. So if my request went to this database for write, then my read request should also come from this database itself. At least till the replication happens for my latest changes in both the databases, this and this. Even if data is written to different partitions while reading, we make sure that those partitions are queried for the writer. This is called user pinning or sticky routing. So if someone asks you what does user pinning and sticky routing mean and what is their importance, so the basic ideology is that if I am a writer and my write went to this database partition, let's say db_1, okay, database will have a lot of partitions, right? It is a resource which will be having, let's say, 200 partitions. So this is the first partition to which my write went. Then reading request will also go to this database only. So I will always read the latest state, and thus we avoid this inconsistency and any confusion to the writer. For the followers, since this is eventually consistent platform, the request can go to other replicas as well. Let's say two replicas are there, replica 1 and replica 2 for this database partition. So readers can read from this, and as the replication catches up, then eventually they will be able to see the latest state. That's fine for them. We are talking for the writer, whoever is putting the post. They should be able to see the latest state of their post. What are the other solutions? Say we assign a token for the write to writer whenever write is successful, and writer also sends this token when reading their write immediately. If the database does not have that token 404, we query the database having that token, and hence no read after write inconsistency. But this 404 can lead to slowness of response, degrading user experience. So UX is nothing but user experience. Generally we use these terms like CX means customer experience, things like that. These are the corporate terminologies. But um, 404 is also HTTP code, which means not found. Okay. Now coming to the topic quickly. So what are the other solutions? We just read this. This basically means that whenever a writer writes something, we assign it a token. Let's say T1. I'm just putting a ID to the token. Now, whenever a writer is putting a read request, let's say it is going to database 1 only, right? If that database also has the same token, then read is successful. Otherwise, we say that this database is may be out of sync with the master or the main database partition. So we will query the another partition and see if that partition has the token. If that does not have, we query the another partition, the leftover partition, the rest of the partitions, and eventually some partition will have that token. So whichever partition has the token, that means that partition is having the latest update from the writer, and from there the read request will be fulfilled. But you are seeing that first we queried this database partition, then this database partition replica, then this database partition replica. So this can lead to some slowness. The latency of the response will be much higher in this case. So it can degrade the user experience. That user might be seeing some slowness in the response. So in this video, we discussed what a read after write consistency mean. We discussed this inconsistency can be resolved by either user pinning or sticky routing or by assignment of a token. We also discussed why this inconsistency occurs. If you like the video, please consider subscribing to the channel. I keep making such videos very often, so please like and share. And if you have any topic which you are finding difficult to understand, please feel free to comment and I will try to make a video on that topic. Thank you so much.